Hi, my name is Ben Kugielski, and this is my application for the Google 10 to the 100th contest. My entry, the mWheel, or magnet wheel, is the simplest and most efficient wheeled vehicle drive system aside from the bicycle. This system has the potential to deliver safe, clean, cheap transportation to the people of the world. Since it has only one moving part, the driving wheel, it will eliminate the majority of repairs and the resulting waste and cost. This system will not require massive assembly lines to keep production costs low. The low cost is a function of the design. Small factories and personal workshops will be able to build this system, putting control in the hands of the people. Historically, our vehicles have been built around the internal combustion engine and the systems needed to support its operation. These requirements drive most of our current vehicle designs. And what is that current system? We take potential energy from gasoline and by burning it in the motor, use it to turn a transmission, incurring a loss. Transmission drives the shaft turns a differential, incurring another loss. The differential drives an axle through a universal joint and finally exerts torque on our driving wheel. A lot of losses in there. That potential energy, actually less than 30% of it, is now kinetic energy in our moving car. When we want to stop, we use a complicated system of hydraulics augmented by electronics if you have anti-lock brakes, to introduce friction, which turns our kinetic energy into heat and worn brake pads. Basically, we burn to go and we burn to stop. On to the mWheel. Fortunately, my technology demonstrator was not completed in time for this contest deadline, but it'll serve the purpose for illustrating this concept. This wheel is the wheel of your car or motorcycle. If you can imagine it that way, this would be your swing arm on a motorcycle, and this would be your wheel. So imagine this as a part of a vehicle. Now we've embedded strong magnets, permanent magnets, along its rim in alternating magnetic orientation, north to south, south to north, and so on, all the way around. Hidden in this wheel's fender, in this part, will be stator coils, electromagnets, or just a ferrous material with copper windings. These will be arranged in multiples of 3 on each side. So we would have 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we'd have 9 on the alternate side pointing in. So that's how it would appear from this orientation. These coils will be energized by 3-phase pulse width modulated DC current, which will serve to step the wheel through the fender. So we will energize these electromagnets in a pattern. It's actually it's 3-phase with 120-degree phase offset, and by doing that, it induces rotation on the wheel. So the wheel of our vehicle is actually now the rotor of a 3-phase brushless motor. And if you already recognize this as a 3-phase brushless motor, you probably already know how efficient they are. They're up to 98% efficient. The technology is already available. The motor controllers, which is required to create that 3-phase signal which drives the coils, it's a mature technology. The mWheel is just a different configuration to take advantage of its inherent simplicity. So now your only moving part, aside from suspension, is your driving wheel. Also, please note that you're driving the wheel from its edge, which is the point of the lowest torque. Think about a screwdriver. You don't turn the screwdriver from the shaft, from the center point. You turn it from the larger radius of the handle. It's a simple machine. That reduces strain on the system and reduces the structural requirements, which we can keep our weight and efficiency, our weight low and our efficiency high. So we've recognized how this system is driven. How do we stop it? Well, if you recognize this as a 3-phase brushless motor, you'll probably also recognize it as a permanent magnet alternator or a simple generator. Once you stop pulsing the coils with electricity, they will induce drag on the wheel. If we put this near, you can, well, it wouldn't actually contact, but you'll get lockup there. The kinetic energy of the wheel and the vehicle is not lost, though. It is changed back into electricity and stored. This is known as regenerative braking and is already in use in hybrid and electric vehicles. A further optimization will be to use supercapacitors, a cross between a battery and a capacitor, as a power buffer or a temporary storage tank. Currently available batteries can't handle all of the charge created by regenerative braking, so only a portion of that electricity is stored. The rest is usually dissipated as heat, like in hybrid cars. A supercapacitor has the discharge characteristics of a battery and the recharge capabilities of a capacitor, so it can handle the current generated by regenerative braking and store it for later use. Now we've gone from potential energy stored in your batteries to kinetic energy, so the wheel's moving, and then change the kinetic energy back into potential for further use. The only losses involved are friction, the bearing, and the tire, and the inefficiencies within the electrical system, which can be very low if implemented properly. To put it simply, the system exploits the law of conservation of energy. On to maintenance. What is there to wear out here? We have the tire, there would be a tire around here, and suspension components, which are now supporting less weight, so they'll last longer, but it will eventually wear out. And you have the bearing, but bearings have come a long way, so that may never even need replacing. You also have the battery, which will probably need replacing after a while, depending on how far battery technology progresses. Let's compare that to standard maintenance on an internal combustion-powered vehicle. You have tires, brake pads, brake rotors, bearings, axles and CV joints, the clutch, pistons and rings, timing belts and chains, the cooling system, radiator, water pump, thermostat, spark plugs, distributor. You have to change the oil. I'm sure I'm missing many others, but you get the idea. What about construction? The only special part in this system are magnets, the motor controller, and batteries. The wheel and chassis could be built in a modest bicycle shop, or existing vehicles could be adapted. The coils would be wound by hand, and they're just a piece of ferrous material, ferrite or iron. You want a material that has low magnetic hysteresis, but it's getting a little technical. And so the coils could be made, and the motor controller is a standalone component you can just buy. You can get it on the internet. The system could make a profit. Good craftsmanship would be a good selling point, but it would also be good for the world. Local craftspeople could construct the system with only a few already commercially available components. The electricity to drive it could be generated anywhere through clean and renewable means. It's silent except for a slight hum from the coils, has zero emissions, toxicity is limited to the battery, and battery recycling infrastructure is already in operation. It won't fill junkyards with worn-out parts, and the entire system would be recyclable. The simplicity of the concept and design will prevent it from being needlessly overcomplicated by those with the desire to keep people in dirty, inefficient, expensive vehicles. It's my hope that the full disclosure of this idea will result in further development and the spirit of open source collaboration. I only wish to further develop and realize this creation for the world. Isn't it time we reinvent the wheel for the future?